This is logs day 3. It's really 3.4 still. We're continuing this. Basically, we'll finish up with 3.4, which is logs. So 1, 2, and 3 of chapter 3 is all log stuff. So it really kind of just mixes together, especially in the packets. What we're going to do is we are need to solve this. So 8 to what power is 0.165. Now, the thing is, before, we were like, if I can get the same base here, that means my exponents would have to be the same, and I could solve it that way. Excuse me. The problem is that 0.165, I don't know if I can figure out any base that goes to a 0.165. Potentially, there could be a 2 that goes to that, or an 8, because that's the only ones that 8 can be broken to, right? 8 can be a power of 8, or 8 can be a power of 2. Can't be a power of 2 necessarily, at least not nicely. Because yes, this 0.165 can be a power of 8. It's just going to be one heck of a decimal.
Question.
And so, I propose that we do something to both sides. Because what you do to one side, you have to do to the other. And this is what I propose, guys. I propose that we use the fact that if I say log base b of b, that would equal what? 1. And log base b of b to the x equals x. I'm going to use that one particularly to cancel out bases. I want to be able to drop that y to normal ground, to the ground level. I don't want it to be an exponent anymore. And so, I will take log base, the number that has a base, an exponent. In this case, it's 8. So I'm going to go back to this. I'm going to go log base 8. But what I do to one side, I have to do to the other. And notice that I squeezed it in front of the 0.168. I will not put a log base at the end on nothing. It's on the front of both sides. Because log base 8 of 8 to the y will cancel, leaving you with y equals log base 8 of 0.165.
Oh, that's y?
That is a y, sorry.
Oh. Well, I thought it was an x, but it looked like a 4.
It's a variable. And, guys, we can handle this. This right here, as the way you see it, is what we call the exact solution. But if I wanted to know how or what number that was, I would have to put this on my calculator, and I would have to use that thing, the very first worksheet we completed, which had what? What did we do to figure that out? What did we do to it? We switched it around. It had a name.
Exponential.
Nope.
Natural.
Change of base.
Yep, that's it.
So it meant I could take the natural log of 0.165 and divide it by natural log of 8. I could have used log of 0.165 divided by log of 8 too, right? That doesn't matter. So you take that, put that on your calculator, you end up with an answer. Does anybody have that real quick? Negative 0.866 ish. Given a approximation there. Negative 0.866. Possibly. It goes on forever, guys. So if I took that answer and I plugged it on as a power of 8, I should get 0.165. Again, this is approximation, so it will result in approximating to 0.165. Not that big of a deal, right? Hit it with a log on both sides to cancel out the base to bring the exponent down. So then the next problem is going to be the exact same thing, but we're going to have to kick it up a notch. We got to make it a little bit more difficult. This time, A is our exponent on 1.43. Added to 3.1 should give us 8.48. Hint, to take a log of both sides, you have to have something equaling something, not something plus something equals something. So, in other words, get rid of 3.1. So get rid of 3.1, and you get 1.43a equals 5.38. Now, when I go to hit it with a log, I will hit it with log base what? Right. Log base 1.43. Log base 1.43. The coolest thing about it, on the left-hand side, it cancels, leaving you with A equals log base 1.43 of 5.38. And then we use the change of base. Let's use log this time. So log of 5.38 over log of 1.43. I did see somebody trying to use a log and a natural log at the same time. You may not do that. You will stick with the same base. It could be either one. It could be any base you want, but it has to be the same base, okay? So just be mindful of that. 4.7-ish. So it's a 4.7. So 1.43 to the 4.7 power plus 3.1 should result in an 8.48. Any particular questions, guys? Next problem. Just using E, not that big of a deal, but our exponent has more than one piece. It's still all an exponent of 2 plus 5w. So when I cancel out the base, that whole thing gets to go to ground level. Okay? So therefore, I want to hit it with what log? Natural log, because natural log is base E. So natural log, that's an easier one to write. Natural log, they cancel each other out. Becomes 2 plus 5w equals the natural log of 12. It's so, I need to solve for w. We have natural log on our calculator. I don't have to use change of base this time. So I could take the calculator, natural log of 12, put it there, subtract 2, divide by 5. But what if I said I didn't want an approximation? Just like the last problems, I could have left them as log of, I forgot what it's like, 5.38 over log of 1.43. I could have left it as that and then applied those other operations to it. Just like I can here. To get w by itself, we should subtract 2. It is not natural log of 10. Natural log of 12, guys, has to go first. So you may want to put parentheses around that, and then you're going to subtract 2. I need to figure out what natural log of 12 is, and then I can take the 2. And then, after I do that, I can divide everything by 5. So w equals natural log of 12 minus 2 all over 5. And if I had to give me approximation to 2 decimals, I can now do that on a calculator. That, it matters. Like natural log is pretty nice, so you might want to just leave it this way. When I use a change of base, under normal circumstances, the last one, if you want to go above and beyond, you will work out the exact answer as far as it can go. and then give the approximation with it. So that would be a better telling of that you can do your algebra and you know how to find an exact answer and not just plug a number on your calculator and work it out. So again, that's going to give you approximation eventually. You can plug in for W to verify. To kick it up one more time, here it is. What happens if you have bases that are not the same, they're on opposite sides, and they both have exponents that have variables? Which means I really officially want to drop both of those to the floor so I can solve for it, right? Yesterday's worksheet said that's not a big deal. I just see, hey, what power of 6 or some form to get 6 and 5 are the same? Can you think of any bases that both have a power that'll give me a 6 and a 5?
60.
What's that? 60. They both go into 60, but I don't think we can take 60 to some power and get 6 and 5.
5 and 6.
You can't. You can't take, think of this. 6 to the first power is already bigger than 5. 6 squared is 36. It's not a 5. 5 to the first, 5 squared. I can't, ladies and gentlemen, I can't make them the same. So therefore, I have to resort to what I just did and hit it with a log. The problem is, what I do to one side, I have to do to the other. That means if I use log base 6, I have to take log base 6 of both sides, or 5. I cannot change it. I can't take a log 6 on one side and a log 5 on the other. So my rule of thumb is, take a look at your exponents and figure out which one looks uglier or which one more complicated. So either the bigger numbers to you are you don't like, or that negative in there you don't like. Most of us probably might say that negative is going to be the problem. So that's where I propose that you hit it with log base 5. Both sides. Because the 5s will cancel, leaving you with a negative x plus 1. Would you guys agree with this? But you know what? On that left-hand side, they don't cancel. Oh, man. But wait, that's a log that has an exponent. What can I do with that then? Bring it up front. I can set it down, can't I? Aha. So when I go to set this down, it'd be 2x plus 4 times log base 5 of 6. And log base 5 of 6 is just a number. And we can find that number using the change of base. So this is 2x plus 4 times natural log of 6 over natural log of 5 equals negative x plus 1. You take your trusty calculator out. What's the natural log of 6 divided by the natural log of 5? 1.32. Notice that I just stuck it right above the top. I did this because what do I have to do with that 1.32? Distribute it through. I'm just trying to save myself a little bit of space. That should become 2.64x plus
5.28.
5.28
Yeah.
equals negative x plus 1. And now, just gathering it up like terms. It's an Algebra 1 problem with decimals. Okay, not a big deal. I'm going to add x and add an x. Subtract 5.28. Are we doing something wrong here, guys?
Why is that?
I don't know. I was thinking that supposed to be a different answer, but maybe I wrote down the original problem differently than what it was. So this will end up being 3.64 x equals a negative 4.28. Divide both sides by 3.64, and x is equal to a negative 1.17.
Yeah. Yes. Well, a negative 1.17. No.
Some people should verify. Could be some verification here. 1.17.
1.17.
Okay. I may have written this down differently than the other 2 hours, so therefore that one does not look the right as in from the other hours, which is fine. We've solved it. This is done correctly. But how do I know if I did this correctly? I will put it back in for x on both sides. Make sure left-hand side equals the right-hand side. Okay? Okay, what I'm going to talk about here, guys, is that I could have instead took log base 6 of both sides. That means on the left side, 2x plus 4 would have dropped, and I would have been left with log base 6 of 5, which I would have to distribute here. 2 different people can do this 2 different ways, and they should still get the same answer. So let's test that theory with this problem. 4 to the 3x plus 2 equals 6 to the 2x minus 1 power. Please solve that. Your choice on which one you feel is not the nice exponent. Get rid of it. Which exponent looks the crazy or scariest one?
Right.
The right again? Okay. So that means we're going to hit log base 6. Log base 6. These cancel away, leaving you with 2x minus 1. Where the other side is going to be 3x plus 2. Now watch what I do here. I'm going to speed things up, and I'm going to go like this. Do you notice that? That is an okay move? Because I am leaving it as log base 6 of 4, and I'm like, hey, I'm going to necessarily need to change it to a decimal. And now what is natural log of 4 over natural log of 6?
No.
0.77. And I'm going to distribute that now. 3 times 0.77. 2.31 x plus 1.54 equals 2x minus 1. I think we can subtract 2x, right? And subtract 1.54. 2 x's, those are gone. So this becomes 0.31x equals negative 2.59. Divide it out. It's a negative 7.3. 7.8. Now, granted,
I did the opposite way and I got that too.
you should get the same answer even if you did log base 4 instead.
Yeah, you do.
Are you going to come out to exactly negative 7.8? Probably not. It matters how many decimals you use to approximate. And if you plug negative 7.8 back in, you may not get both sides to be perfectly the same. It's an approximation. We'll talk about that in a second. Your homework, joke, 13 and number 4. Have a great day.